So it's part 2 of lesson 7. So for this part, we're going to kind of step away from Visual Studio, and we're going to talk about version and source control, which doesn't sound like maybe that sexy of a topic, but it's really critical to what we do as programmers. So there's a bunch of different version control systems out there. So we're going to talk about what this is and why it's important. The system that we're going to use is called GitHub. Okay, there are a bunch of other avenues out there, but GitHub is probably the most common one. So there's a few reasons why we need to learn how to do this. One is when you go job hunting, chances are your employer is going to expect you to know some version control system, maybe GitHub, but they all work in similar ways, so we can easily learn other ones. The other thing that employers often ask for, and we've heard this over and over again from companies, is when people are applying for jobs as designers and developers, one of the first things they're often going to say is, I want to see your GitHub, because that is where you post all of your code and all of your work. So we're going to get set up with GitHub accounts. Everything we need is free. So we're going to get set up with this today. We'll look at we're actually going to take the Visual Studio project we did in part 1 of our lesson today and look at how do we create an archive of it on GitHub. And then we can even, if we have time, look at some of the sharing tools, because version control is also used when we're working with other people, right? So we have a mechanism to share and merge our changes, keep track of what's going on, and hopefully not overwrite each other's work when we're working with other people. So this is so GitHub is a free cloud service that allows us to keep archives of all of our work online. And we can make it public if we want, or we can make our work private. This is also typically where we find lots of open source code. So if we're looking for a code library to do something, many times if developers have created those code libraries, they publish them on GitHub. So you can go grab a copy and also read the documentation about, hey, this is how I use this stuff. So this idea of kind of version control, it's been around for a long time. And one of the things version control does is it timestamps all of our changes. And the benefit of using a cloud service like GitHub is we don't have to store all those versions on our own computers. We store it on GitHub, and GitHub has no storage requirements. You can upload as much stuff as you want there. They don't care. So it allows us to do things like we can compare different versions. So if Brandon and Andre are working on something and they each change the same file at the same time, GitHub will allow them to look at those files and see, okay, this was changed here on this day and this was changed here on that day. It will also allow them to merge those changes together. Or they can restore and go back. I broke something, I need to get the old version. So we're going to be able to do that. So GitHub is based on this control management system called Git, which is free, which we're all going to install on our machines. And we're going to use this for all of our courses, okay? So in order to get Git on your machine, I may have put the link up on Blackboard already, but if not, I'll throw it up there now. I'm also going to stop posting my code on Blackboard, and each week I'm just going to post my code on my GitHub page. So my link to it is right here. We've been here before but haven't talked about it. So each individual project in GitHub language is called a repository. So for my other classes, so my Thursday class, my Wednesday class, so it's actually easier for me to upload my files here, and then you can get them, all my code. I just make it all public, so you don't even have to log into Blackboard to get it. So first things first, we need to install Git on our machine. So let me just go here and grab the link. Source control. Put a couple links here. If you can just go into your weekly learning and tools and resources folder, scroll down to the bottom, and let's open up this first link, this Git-SCM, which stands for Source Control Management. Open that and you get this site. So if you just go to downloads, you can download and install Git. It doesn't take very long. So Git allows you to take local archives of your code. So again, we can go and restore from a previous version at any point. This runs on this was originally a Linux-based tool. It's now available on any operating system. So if you're a Mac user and you're running Windows for this class, so you can run Visual Studio, you can install the Windows version, but you can also install on your OS X, you can install Git for OS X. And I would recommend you do, because you'll be using it in some other classes later, even if you're running your Mac OS. My first introduction to using source control was probably about 15 years ago. I had moved to Barrie and I was working on a project, and there were 8 web developers working on one project. And I wasn't in the office because I was working from home. So we needed a system to make sure that only one person was working on one file at a time. So we used an old Microsoft version control system that had a check-in and check-out process. So we could all see all the files in the web application, but if Kurt clicked on it, he had checked out the copy. And if Stuart needed it, he could only get a read-only copy until Kurt was finished making changes and checked it back in. So that was kind of a primitive version. Git's a lot more advanced. It allows 2 people to work on a file together and merge their stuff, for example. Sorry. Yeah, you shouldn't need to change anything. So just pick your operating system. Yeah, you don't have to change any of the options on the install. Just accept all the defaults.
Git installed in like a cloud platform that I use. I'm wondering, is there a way that I can link like this install to the account that I already have with GitHub?
Yes.
Okay.
Is it still running? Is it still running your install?
Yes. There's all 3.
Okay. We'll let it run.
So we try to download the same one.
Yeah.
But mine says Git bash. And his says Git CMD.
Yeah, there's a few different ways you can access it.
Yeah.
We'll probably use the Git CMD, but you can use the Git bash as well. You can kind of run the commands from either place.
Oh, okay.
So the way to make sure that Git's actually running on your machine, once the install is done, here's how we check. You click the Start button in Windows and type CMD, which gives you goes to your Windows command prompt where you can type old school DOS commands. So you get this black screen. To check if Git is installed, we type the word Git space -v. -v is for version. It should tell us what version of Git we have. Oops, sorry, I guess it's Git -- version. So you probably have a newer version than me, that's fine. As long as you don't get an error, it means Git is running. And we can start tracking our changes.
So even when I did that, it gave me the same result as before. So
You typed Git space -- version.
yeah. And when I did the first time. Oh, that's why. Okay.
Yeah. Git -- version. Now, I know using the command window can be kind of intimidating. The good news is we're only going to use a few commands here, and it gets familiar really fast. And it's a good idea for us to learn how to use the command window, because next January when we do Node.js, a lot of our setup is done through the command window, setting up websites, running servers, etc. We do it by typing commands in this window. So getting a little bit comfortable with it is probably actually a good thing. So once Git is running, we now want to set up accounts on github.com. So GitHub is a cloud service that allows us to keep archives of our code. So if you use this second link that says education.github.com, it's going to take you here. Now, anybody can sign up for a free GitHub account, but if you are a student, you get some extra perks for free, so you may as well get them. Okay, so if you go to education.github.com and click this Get the Pack button. So here's what they give us. They give you Amazon Web Services hosting credits of $100. The DigitalOcean $50 credit, that's another cloud hosting service. Well, we already have Microsoft Imagine. This is neat. Through Namecheap, they give you 1 year free of an SSL certificate and 1 year of your own domain name. So if you want to register mikebachelor.ca, they'll give it to you free for a year with your GitHub student account. Buy the name on Namecheap. So you get access to all this stuff, bunch of credits. If you want to do gaming, there's this Unreal Engine. You can get that software for free as a student. So you may as well go ahead and get this stuff. There's a lot of cool stuff involved. So click on Get Your Pack. Click Yes, I'm a Student. And then put in your Georgian email and fill out their small registration page. It will send a verification email to your Georgian email. So you need to click on that link to finish the verification process.
So if I already have a GitHub account, I'm able to link that.
You can link them. So yeah, so if you have a GitHub account already, still go through the Get the Education Pack. And then, so Zach, for you, for Jenna, for anybody else, here's how you link them together. So if you're logged into your regular GitHub account after you verify your student status.
It actually brought me to a page where it was like, it had like, where it's choose your school and stuff like that. And then you can just click,
yeah,
your email isn't here, just
yeah,
add it in and verify it.
The other way you can do it, if you go through in your account settings under emails, you can also add your student address here, so long as you verified that as a student address. So that'll work if you already have a Git. So I have two, right? I've got a school account and I've got a personal account. Jonathan?
You just create an account, or is it supposed to be? Because I didn't get that one.
Okay, so click Get Your Pack. Okay, yeah, so click create account.
Yes.
That's interesting.
Yeah, I
Open this up in a different browser or a private window. You're in.
Yeah, we can count.
So which browser? You're in Opera now or you're in Chrome? Okay, so yeah, just try to explore for a minute. So Kyle, you got the same thing?
Yeah, I'll try it.
Yeah, try private window. So after you click the Yes, I'm a Student button,
We're not getting
you have to sign in first.
Sign in first?
Yeah.
Okay, so you may have to create the account first. I guess they've changed the process. So create your account first, which is free. And then once you have your account, then you can go to education.github.com and go through the get the pack and verify as a student. Vivian? You can create it with a different email, but then you have to add your student email afterwards. So in my settings, I have my main email and then I have my college email. Or you could just use your student email at the beginning, up to you.
After you register it,
Okay, so I guess they've changed the process. So create the account first and then verify your student status second. So there's two reasons to verify your student status. One is you get all of those goodies with the developer pack. The second thing is students get private repositories for free. If you're not a student, you can make private projects, but they want you to pay for them. If you're a student, you don't have to pay for them.
So I made an account on the actual GitHub account or website, so like did my actual real email, but then I also put my school email, and I can't get it to verify. Every time I hit verification email sent,
You've checked your student account and nothing's coming through? Okay, well, it won't go to your other one. It should go, let's see.
Okay, so click reset. Okay, you can also try the troy.cook at mygeorgia.ca. Add it here.
Has anybody gotten a verification email? Okay.
so when you get your pack, you're applying for it, and why just gather, because it said, like, so it says apply or send an application, it says it takes up to 5 days for them to respond.
It doesn't. It should happen right away. I know the message says we'll review it and get back to you, but it shouldn't.
I got it started.
Sorry?
I got it started.
Yeah, you should get the email pretty much right away.
Oh, there you go, yeah, I got it.
The one with the number.
Yes.
Yeah, you can always add, you can try adding both.
Yeah, what's the other one though? Is it for ours is add?
It's first name dot last name at mygeorgian.ca.
For email? Yeah, because we have the two, right?
Yeah, just remember if you're using the number, Troy, I think the problem is you're missing the student dot in your email address.
Well, I did that, but when I did the other one, it's Troy Cook at my original.
Okay. Yeah, remember if you're using the email address with your student number, it's student number at student.mygeorgian.on.ca. Sorry, georgianc.on.ca. Don't forget the student dot is the first part after the at symbol. Anybody need help with their account? Need me to come have a look?
They say they are unable to use it.
What email address did you use? What a student.
Number, yeah. I already have .com, but I use it just to
Okay.
No way.
So try the other email. Try first name dot last. Try first name dot last name
Okay.
at my Georgia.
I had to also search GitHub to pull in the email because it wasn't showing up. It was like 15 of them.
Do you have your focus video?
There. Could be. Like, there's a button that says filter at the top of here. Yes.
If you click it, if you go down, it says show focus box, just one check it out.
Focused or other, yes. Yes, that was it.
I got you.
That would have been why.
Yeah, exactly what it is. Yeah, exactly what it is.
This one, student is before Georgia.
You can use whatever you want. And then you just add it to the account.
Try putting the same student email address as graduating in 2022.
We use burnout to use our site. Make sure they all graduate.
Still saying it can't verify.
Do you know it's okay, cool. Now what do we do?
I think cyber.
I need to do that for all of them. Here's asking me to email I think so, yeah. You just have to save all
Try forget your password. Your account may not have been created. Try forgot password if it's not letting you in. Try that link. Okay, so your account's not set up. It's saying that email doesn't exist. So you need to register the account again. So you need to create your GitHub account again.
I see one.
Say you don't have a GitHub.
It's in Canada. They're just nicely lined up. They're all walking their own.
You want us to
Doesn't get more black
verify
in Canada.
using our like student ID too, right? Like it's asking me for
Yeah.
upload an image of your school ID.
You have to do your email first and then I'll like pick it.
If you verified your email, that's all you need to do. Yep, for school. So let's look at how this actually works. So what we want to do is take our little week 7 solution we've worked on today and upload it to GitHub. And then we're going to look at what happens when we make a change. How do we copy that change? So once you're logged into GitHub, if you just click beside your profile avatar at the top, we want a new repository. So basically a repository is one project. So usually for every application we build, we create a new repository. So we'll click on new repository. We have to give it a name. I'm going to call it COMP1030 lesson 7. You. You can't have any spaces in your repository name. So you've got two options. So if it's public, anybody that comes across your GitHub page can view your code, which for based on what we did today is fine. Right? If it's an actual working application, we may have sensitive information in there, like credentials or things like that. So in that case, we want it to be private. So the reason why I wanted you to have a student account is if you have a student account, when you pick private, you don't get these payment prompts. For today, you can just make it public, but when you hand in assignment 2, you're going to create an assignment 2 repository and you're going to make it private. So no one else in the class can come on your repository and take your code. So what happens with these is when you make them private, you're the only one who can see it unless you invite other users. So you have to invite me to your repository and GitHub sends me an invitation link. Then I can see it and you can see it. Believe it or not, in one of my other classes the other day, I was marking their assignments and I noticed that and so all the repositories are private, except one student's repository had 2 different contributors. And student B was making changes to student A's repository, which means I'll have lots of fun while I mark that one. We'll talk about this later, this initialize with the README. We're going to leave that alone for now. So I'll just click create. Actually, I'll just open up another repository of mine for a minute so you can see. So this is what I've been working with in my year 2. We've been building out this music store. So this is the README file. The README is usually an explanation of what this application is, and also if there's any documentation about how to use the code, if we're making the code publicly available, that's typically what goes in the README file. And we can put regular HTML in there. Just has this MD extension, stands for Markdown. So here's my little README file. And you can see in this, I've got 9 commits, so 9 different versions. So as we've been working through, so this was kind of the end of when we took our break in my Tuesday class, end of lesson 7. So every time we make a new version, we typically put in a message explaining what changes we made. Because if you just put in version 1, version 2, version 3, if we break something, we don't know what version to go back to. So it's a good idea to describe what's going on. So if somebody missed lesson 4, they can go in and grab this version and they know exactly this is where the project stood at the end of lesson 4. So each new version in Git speak is called a commit. So we've created this new repository here. So here's the URL of it. So then they give us a few commands as to how we can take work on our local computer and in effect upload a copy of it to GitHub. So here's what we'll do. If you can browse on your computer, browse into wherever folder the project we created today is in. So for me, I'm in COMP1030, week 7, week 7. This is my solution data today, right? I've got my SLN file and I have my folder with my little form 1. If you're not sure where on your file system the project is, you can just go into Visual Studio, and if you click on your solution, it shows you the path right here. So you'll want to go into your computer in your File Explorer, browse into that folder. So go there. If you just click in your address bar, we want to copy that path. So just click up the top of the address bar, right click once the path is, and click copy. This just saves us having to type out this whole path, which will be easy for us to mess up. So now you should have one of these little command windows open. If you don't, the easy way to get it back is click Start and just search for CMD. We're going to use this a lot, so you may even want to pin that to your Start menu or your taskbar. So when you open up the command prompt, every time it takes you into your users directory with your current username. We want to leave this directory. We want to go into the one where our work for today is. So we can then upload our current project to GitHub. So the command for this is cd, we're going to change directories. And now if I right click, I can paste in that path that you see up above and hit enter. So we're no longer in the users directory, we're now inside the folder where our work for today is. If I want to see what's inside of it, if I type this little command dir, that will show me all the files and folders in this directory. So you can see they're the same. I've got my week 7 solution file and then my week 7 subfolder. So now all we really need to do is follow most of these commands that GitHub gives us that will copy our code from our laptops to the cloud service. So I'll kind of keep them up. So the first thing we're going to do is type this second command that says git init. We're going to initialize git in here. That means that the Git program we installed on our machines can now watch for any changes that happen inside here. So we'll run the command git init. So it says, okay, we've created an empty Git repository in this folder. So we can now monitor changes. So we now have 2 repositories. Them. So whatever is here also lives here. So one of the other great things that GitHub is great for is backups, right? You should never have the excuse, my computer isn't working or it got stolen or I got lost and I lost my work. You say to a teacher, you say to a customer, sorry, I can't make changes on this because I don't have a copy. Whenever I'm done working on a client, if a client wants me to do changes, at the end of the day, every day, what do? Upload the new version to GitHub. So if my computer blows up, my house gets swept away in a tornado, all my code is backed up on GitHub. And I can just grab a new computer, log into GitHub, download all the code. Right? We should never be dependent on a particular device, ever. So this is a great backup tool. So we've run this first command. The second command we're going to modify a little. Notice it says our repository is empty. So we now want to take all the files we did in the first hour of class, we want to add them into this version. So we'll run the command git add. We want to add all the folders and all the files. And the way we do that is kind of weird in the Git language. The character dot is like a wildcard. Add everything. Doesn't matter what the file extension is or the file name. So we're going to run the command git space add space dot. Add all the files to this project. Our project's really small, so it runs immediately. If this is a big application, that's going to take a few minutes potentially. So the next thing we're going to do is make a commit. We're going to make a new version. So we're on the command git commit -m. The M just stands for message. Every time we make a new version, we have to give it a message that describes what's in this version. But typically, for our first one, we name that as first commit. But I don't suggest doing second commit, third commit, because it's not descriptive. And hit enter. So now all of the files in our project got added to this version. Now, if I refresh my browser here, notice there's still nothing here. It's still giving me. So we have 2 more commands to run.
I got it there. Something to do with my email.
Ah, sorry. Right. I'm already logged in. So one thing we need to do the very first time is we want to save our GitHub credentials. It's asking you to log in. Right? So once it didn't ask me to log in because it stored my credentials in here forever, which is good. So if it's asking, what does the message say? So it's, yeah, so there's 2 commands we need to run. Okay.
Oh, mine says something like unable to auto detect.
Yeah, mine too.
Yeah.
Okay. So we're going to globally, so for all time, we're going to configure our local Git with our account.
Leave our directory or?
Nope, you don't have to. You can stay where you are. So I want you to run this command in step 2. Git space config space minus minus. Just copy what's in white, and in yellow, substitute in your GitHub username.
Literally like where you are, less than 7.
Yep.
I don't know how you uploaded whereas,
I haven't uploaded anything yet.
yeah, but like, mine doesn't look like that.
Okay, I'll have to look at it.
So after doing that, checking to see that, step 4.
Yep.
It still gives me the same error message.
It probably wants you to do the same with your email.
No, like I just did 2 and 3. Like I put my username. Oh, with the email.
Yeah, so it wants your GitHub username and your email address. So you repeat this step and just substitute instead of user.name, we do user.email and put in the email address of your GitHub account.
And it doesn't matter if it's our student one or not.
As long as it's one of the ones attached to your account. Probably your primary, whatever's listed as your primary is probably the best idea. So we only have to do this once. We won't have to do this again.
So instead of username, you can write
User.email.
Yeah, that works.
What was the command to run, like start running Git as a program so I can do all the initial?
Git space init. But before you do that, Jen, you need to be inside your project folder. So the first thing we did was browse into the folder of our week 7 project. Do you need me to show you how to do that again?
Sure. I'm at like the and I have like a link to my folder.
Okay. First thing you need to do is in your File Explorer, browse into the folder where the work we did today lives. So find your project for today first. Let me know when you found that. Okay, I'm going to finish up. You need to grab the path to that folder because we need it in the command prompt. So you need to go to the folder that looks like mine. You should see the solution file and a subfolder of the same name. And you need to copy that file path.
Mine doesn't have the .ds or .git. It just like I just have like less than 7 and less than
That's fine. That gets added after you initialize Git. Initializing Git creates this folder. So if you haven't initialized Git yet, that's fine. So copy the path. You know, I'll come back to you in a second. I want to finish this process. So we've done these 3 steps. We've initialized Git, we've added the files, and we've created our first version, kind of our first snapshot in time of what this application looks like. What do you suppose these 2 lines are going to do?
Well, the last one's actually push the folder to the site.
Right, so push means upload. Take our local code, copy it to GitHub. It's like an FTP transfer.
And I guess the other one's telling you where to put it.
Right.
GitHub account.
Right, so we only need to do this once. This will link our local Git repository to the online version on GitHub.
You only have to ever have to go through the process when you first like create.
Well,
separate pushing.
Okay, of these 5 steps, this one only happens at the beginning, and this one only happens at the beginning. Because this sets Git up locally, this connects our local folder to the GitHub repository. But every time we make changes, and we'll do that in a minute, we'll change. So we're going to upload a first version to GitHub, then we're going to go back into Visual Studio and change something. And then we want to upload a second version.
It's not per project basis.
It's on a per project basis.
Each directory, so that directory on our computer is
Right.
set up for the directory on GitHub, and each time we make a project, on your
Right.
directory, it goes through all these steps.
Right. So next semester, when you're doing assignment 1 for me, and you're doing assignment 1 for Scott, you're going to have a COMP1030 assignment 1 repository for your PHP project. In Scott's JavaScript class, you're going to have a COMP1073 assignment 1 repository. They're 2 totally different projects, but you own both of them. So I'm just going to copy this line from the GitHub instructions. I'll highlight it and copy it. And then I'm just going to right-click and paste. So this links my local folder to that particular repository on GitHub. They're now connected. So I hit enter. Nothing really happens. As long as we don't get an error, that's good. Now, if I refresh here, our code's not here. So the folders are linked together, but we haven't uploaded yet. So now we need this last command. Push from the origin, the local folder. I'll explain what master means a bit later. No, it's different. I'll explain that a bit later. So then I'll just right and paste. And this should actually upload. It says there's 28 files. And it's uploaded from my local to GitHub. Now the easy way to check this, now when you look at my repository, all of the code we wrote is now copied to GitHub. And it says 1 commit, so there's 1 version. That's my first commit. So we can actually browse all our code without Visual Studio. We can just look and read in our browser. You can't see the forms, but here's all the C# code we wrote today. It shows up. So now it's also backed up. If I corrupt my version or lose my computer, I can just go download my project back onto another machine and I haven't lost it.
You just have to pretty much copy and paste that.
No, I don't have to copy and paste anything. I can download this
Oh,
as a zip. I can open it direct in Visual Studio. Or here's a zip file, I can open it up. There's everything. Just copy it to my computer. I have all the files.
I got 3 errors. There's respect origin does not match any, master does not match any, and it fails to push some.
Okay, I'll have a look in a minute, Jaden. So now we have one version. So let's change. We've set this up. Let's go back to our project and make one change in the project and then save and upload that new version to GitHub. Now, normally we don't push every single change we make to GitHub. It takes too long. But typically I suggest when we're working on a project, whenever we're done working on it for the day, make a new commit and push to GitHub so your work is backed up at the end of every day. So let's just go to our form. Let's go to our toolbox and maybe just stick a label on here. And we'll put on a message. This project is now on GitHub. We don't need to change anything else. So now we have a change in our local copy that we don't have on GitHub. So just hit save. We're not changing any of the C# code at all. Just change anything on here. Change the background color of the page, change one thing. So now if we look at these commands, we don't need to reinitialize Git. Git's already initialized. We do need to add the files again because we've changed them. Then we'll create a second version with a different message. We're not going to call that version first commit. And then we'll simply do another push. And then our GitHub site should show 2 commits or 2 versions. So I'll go back to my command prompt. I'm going to run the command git add dot again. And I'm going to commit a new version, git -m. I added the GitHub label. That describes the change I made to the code. So it tells me that 2 files got modified, which would be my form and my form designer. And now we can just run the push command again. And then we'll talk about the master branch. And then I'll do some troubleshooting because I know a few people are having issues. Okay, Jen, I will come back to your question. Jaden, I know you said you had errors. Okay. So I'm going to try to upload again. And it says my push was successful. So if I go back and look at my repository now, there should be 2 commits. So now I can see both versions. The first version as well as the second version are now here. I'll put the commands back up. I wanted to come back to your question about master. One of the other things GitHub allows us to do is create different what they call branches. So this is really helpful in a few different ways. One is, let's say Zach, Jonathan, and Kyle are working on something together, right? But they're each working on different sections. Zach can create a Zach branch, so you can work on stuff and it doesn't interfere with the other people in the group. Right? Then typically what happens is one person is responsible for merging all of your changes together. Another thing we might have is we might have a website that's actually in production. It's live. So as we're testing and making changes, we don't want to push that stuff into our master. The master is kind of like the final working version. We might have a testing branch where we're testing new features, but we don't want to put them into the master until they're fully done. So we want to make commits every day, but maybe that stuff isn't finished. So the master is usually our final version, but we could have other branches for either different people or different purposes. One of the other cool things about GitHub is if we use a cloud service for hosting, we can actually tie a website straight into a GitHub project. So instead of uploading our changes by FTP, we can simply push them to GitHub, and every 60 seconds, our cloud will look for a new version on GitHub. So we no longer even need to use FTP to put our changes on the web server. We just back them up to GitHub, and our web server also pulls from GitHub. We'll do that probably next semester.
So can you only merge like files that have been changed through separate branches?
No, you can merge it through a single branch. We can also do things, so we've done a push, so a push is an upload. We can also do a pull. So let's say you and I are working on a project together. One of us is going to be responsible kind of like for the final version. So what happens is if you're working on something, you can put it on GitHub and you can send me a pull request, which allow me to review your changes, and I can either approve them and merge them in with the master branch, or I can reject them. We can manage all that through here. So in our repository, you can see pull requests. We can add multiple people onto the team. We can even do issue tracking here for finding and identifying problems. It's got a little bug tracker. So let's do one more thing with this, which won't take long. Let's add a Readme file. So we're going to add this file online, and then we need to download it. We've been pushing from our computers to GitHub. We're going to need to do a pull because we're going to make a change online that we don't have on our laptop. And we want to keep those versions in sync. So once, if you've been able to push, click Add a Readme. And we can put regular HTML in here. So I'm going to just create this file right on GitHub. Just a little explanation of what's in this repository. And notice, again, it will make a new commit. It will make a third version of my project now. And we've got the option to commit it into the master or create a separate branch if we want. We don't really need a separate branch. So it's going to make a new version with the message create README. So I'll just click that. So now we get this little documentation file here. And now I've got 3 commits. So there was our original version, there was the version we added the GitHub label to our project, and now there's a third version where we have this README. So now our GitHub version is more up to date than our local version. Right? When we look on our local file system, we don't see that README. So if we want to download the current version to our computer, we're going to do the opposite of a push. We're going to run the command git space pull. Typically, if we're collaborating with someone else, the first thing we do before we start working every day is we run the command git pull. Because maybe Brandon and I are working together. I work during the day, Brandon works at night. So at 5 o'clock, I push my changes up. When I come back in the morning, there's a good chance Brandon's done work in between that I don't have. So the first thing I'm going to do before I start work is run git pull to download any of his changes and sync them with my project. So when I type git pull, notice it should bring down the Readme file to my local version. Let's see if I refresh. I'll do a directory command. So now when I run a directory command again, my Readme file that I created on GitHub has been downloaded to my computer. So now Readme's here. So push simply means upload to GitHub. Pull simply means download from GitHub. Typically, if we're working on a project on our own, we don't usually need to pull, because we usually just create everything on our laptops and all we do is push all the time. Pull is really when we're collaborating with someone else. That's how we can make sure we're staying in sync and getting each other's changes. Okay. So I've recorded all of this. I'm going to give you your lab. You have a whole week to do it. So the lab is for you to try out GitHub on your own. So here's what you have to do. Go to GitHub, make a new repository, call it lab 4 or COMP1030 lab 4, whatever you call it. You're then going to push this lab document. This is just a text file. Download this text file and push this to your lab 4 repository. So on your first commit, the first thing that's going to be in here is this file. Then you'll open up the document on GitHub. You'll just go here. You can actually edit the file. So you just click on edit, make a change to it, and when you're done, commit your change. So now you have 2 versions. The original version you uploaded, the second version you changed on GitHub, so now there'll be 2 commits. And then pull the file down again, so now you've got the new version. Change it one more time and push it back. So you'll have 3 commits. 2 changes you made on your laptop and the second change you made on GitHub. All you need to do to submit the lab is just go and grab the URL of your repository. Copy and paste that into Blackboard. And then I'll click on your repository and I should be able to see that you've got 3 commits with the 3 different versions. Oops. So this is what it looks like. If I go into a version, it will actually show me what got changed. So in version 2, this file didn't exist. In version 3, I added all of this text in my Readme file. So we can compare, and it will color code. Green is anything new, red is anything that got removed. So if you put something in a file and someone you're working with removed it, GitHub will show you what they took out. And it will show you in red what got taken out. So you have until next week to do this. I'm going to stop the video stream.